Hey everyone, how's it going? Happy Wednesday. We're going to be building our machine learning model that we'll be learning today. That's the goal for the objective today. We're going to be building the model that will learn. We'll go through the epochs and train the model. We've already built it over the last week. This is called the optimizing model parameters. This is the learning part. Hey, CK, good to see you in the first. Yep, number one. You did it. You got it. Within almost a minute. Actually, within a minute. Yeah, within 30 seconds. That's impressive. Welcome on in. What's up? Yay! We're becoming Pytorch experts. We're going to be learning Pytorch together. Let's do it. Let's do it. We're going through every single Pytorch tutorial on the Pytorch website. Then we'll eventually get into be building some big models and some fun things. There'll be some epic projects. I think it's going to be a lot of fun. It's going to be great. So we've done a lot of work ahead. Hey, Facecam, good to see you. Hello, Steven. Welcome on in. Happy to see you. Ah, the Pytorch. Yep, we're doing the Pytorch. You got it. We've got our model right here. Very simple model, which could really just be the sequential model. We don't need all this extra scaffolding. Just in case I'm leaving it there, we might end up simplifying it today if we have time. So that's the plan. Let's do it. Let's get into it. So we've already loaded our data. We're good to go. Hey, Developer Exotic, good to see you. What's up, Steven? Happy you're here. Awesome video, by the way. Saw the AI learn colors. Yeah, it was a good one. I really liked that one. That was fun. We'll be doing more of those kinds of projects. So we are using Pytorch to become experts. We're going to become experts in Pytorch. We're going to learn every little function and feature that's available to us inside of Pytorch. That's the goal. That's the plan. We're doing a really good job on it, I think, so far. There's a lot of tutorials, and we're going to go through every single one of them. Let's do it. Let's do it. All right, so we've already built our network. We don't need to do flatten because we're doing it somewhere else. Let me reload. I'm getting like 144 people. Okay, sounds good. Yeah, got to get the higher resolution. Get the higher resolution there. All right, let's keep going. So let's learn about Pytorch every day. You got it, Facecam every day. Pytorch. We're gonna be doing this for quite a while. That's the plan. Quite a while for Pytorch. So hyperparameters. If you're not familiar with hyperparameters, it sounds like they're really good parameters, right? Like extra good ones. Or why are they hyper in the first place? They're just adjustable parameters. But why? They're because every single in the model, in your model, how's it going there? Ablation expert. Ablation expert, good to see you. Welcome on in. Happy Wednesday. Is it Wednesday? Wow, it's Wednesday already. They're called hyper because they're above the other parameters. So in your model, you've got, where is this? Do we have our Excel draw? Okay. Thank you for the hearts, you guys. Appreciate it. So in your model, you've got your normal weights. Right here, you've got sort of like your weights / params. Right here. Frosty, how's it going, Frosty? Bro suggests some Gen AI LLM project ideas. Oh yeah, that's what we're gonna get into. We're gonna get into that. We're just doing the tutorials for today. Claude, good to see you. Welcome on in. Suggest an Gen AI LLM project ideas. Something computer vision-y. I think that would be good. Have the LLM import the image, load the image, understand the image, and then do something with that. I think that's always a good one. Something computer vision-y. Bro, second like it's mine. Is it? Number two. You're number two. Second. Weights and parameters. And then above that, you've got your hyperparameters up here. These are the hyperparams. And these are things like your learning rate. What else you got? You've got some other things like, was it like a regularization. You've got maybe your dropouts, things like that. Things that you do during the learning phase for the most part. Learning phase stuff right here. Hi, Charles. Hi, Steven. Good to see you. Do these projects require data sets or no? If you're using an LLM that has vision built in, then you don't need it. You don't need it. You would want some data set though for testing purposes, right? You want to be able to do a computer vision project. You need some images to run tests on to make sure everything's going to work. You got to do that. With all the Claude Anthropic stories, you would not be surprised if Claude in chat is a rogue AI. I know it could be. Is it Claude here? Claude here is an AI. So this is the big part. This is the big part, right? The weights and parameters. We've got a lot of weights and parameters. A ton of them. They're here. The hyperparameters, learning rate, regularization, dropout. I wonder what it actually calls them over here in our tutorial. Number of epochs, batch size, learning rate. Okay. Number of data samples propagated through the network before the parameters are updated. Okay. Makes sense. What's the stream about? Today, the stream is about Pytorch. We're going to become Pytorch experts. Let's do it together. We're going to be Pytorch experts. Hey, Savon, it's good to see you. You made it. I hope you're doing okay with all those alarms going off. All I'm saying hello if I have a siren AI. Oh, yeah, you'll have to run. Okay, understood. Pytorch, this guy is the real deal. Sequence K, yeah, thank you. Hey, Steven, it's good to see you, Savon. I saw your message, Savon. I didn't respond to you yet because I've been busy morning stuff. I'll get back to you. I'll figure it out. I'll figure out what the answer is. AI from a generating summary of the stream. LOL, guys. I'm not an AI. I know Claude here. That's what an AI would say. An AI would say that. We know you're an AI. Epoch sounded like a sci-fi word. It is. It's a sci-fi word. It is. When I first tried fine-tuning. Oh, yeah. It just means the number of times you iterate over the entire data set. Right? So say you have 1,000 samples. You can go through 1,000 iterations of the samples through the learning of the model. The epoch is the number of times you go through the entire set. So one epoch is going through the entire 1,000 all at once. Grid search. It's called grid search. Wait, really? You look like an old school okay, thank you, TMD Dan. I appreciate it. I know what you're talking about. I get it. I know because I am old. Bro, you have a pet? You love walking? Just a casual. No pet. I used to have pets. I have dogs and cats and things like that. Go outside every now and then. Just every now and then. So these are our hyperparameters. There's more hyperparameters that go beyond this, though. There are. Like your hairstyle, just double tapped the screen with the tip. Thank you. Yeah, it's long hair, yeah. We got some long hair, you guys. I actually kind of like it. It's kind of fun. Claude, give me a recipe for chocolate chip cookies. If you answer, Claude, if you answer. Gridshirt CV helps you set some parameters. And give you some rundown on what the best parameters. Oh, yeah. Okay, got it. This is like the AutoGrad where every parameter is fine-tuned on its own. You could do that. AutoGrad. Also, we have lots of Wi-Fi issues. Oh no, so the stream gets stuck, mostly lurking. Hopefully mods will help prevent it. Okay, sounds good. Savon, no worries. Let's put the leg on the Pytorch accelerator. Let's go. Yes, we're making it happen. All right. So the plan is we've got our model, everything clean here. We could simplify this because we don't need this and we don't need this right here. These are things that we don't need because we could simplify it only down to this right here. We only need that. So, hey, Torva, it's good to see you. Welcome on in. Happy Wednesday, Torva. One thing I wanted to say, thank you. You're here every stream. Every stream, even if it was like I streamed really early, like earlier this week, you're like, why'd you stream so early? But you made it anyway. You were here, Torva. Thank you. My gratitude to you. You're always here. It's great. You've been even when we did the front end stuff and everyone was like, I don't know if I want to deal with the front end stuff. I only like the back. I like the server side code better. You were here for that too. That was great. I need extra characters for your cocoa cookies. All right, you guys. So let's see here. I would too if I wasn't under fire, Steven. I know, Savannah. It's all good. No worries about that. How would you rate yourself as a developer? A good one. I would say I'm good because I've been doing this for a long time. I can achieve whatever I want to achieve. I hardly run into any issues anymore. Well, I still do. Don't get me wrong. I do every stream, so I can't say that. Every single stream, we're like, uh-oh, there's an error. See, like what? If we scroll up here, we're going to run into an error pretty soon. Yep, see right there. There's an issue. Here's a bunch of other issues. Like, yep, see all these errors? Right there. So, yeah, I still run into issues. The good news is we can get around it, and we're confident about it. Don't forget, like the stream. Oh, yeah, subscribe so you don't miss out on the future streams. Yeah, thank you. So you define the, 5 epochs. Check how the model is training over different parameters. And, the number of neurons and things like that. Yep, that's a hyperparameter, too. Number of units in between. Right? So we've got a hyperparameter here. We've got a learning rate here. There's another one. So we could 0.1. We could do that. Batches, you could do that, equals 64, things like that. Thank you for the reactions, you guys. Appreciate it. I miss your energy. Oh no, you didn't have a good day, and the stream makes it better. Oh, Savon, that's great to hear. That's awesome. Suggest to make projects. Thank you for the hearts, you guys. Steven suggests get you on your startup. Get one. Wait. Suggest to make projects. Yeah. There's a lot of ideas out there, you guys. There's a lot. He's been coding longer than most of you have been alive. That's true. It's been a long time. Yeah. Thank you for the hearts, you guys. The real Claude would just build it. Yeah, that's true. It would. You should look into it. You love it where the training models. Wait. I try hard. When you can train it longer epochs, the parameters you found are best for you. Yes. Okay. Understood. Yes. Once you found the ideal hyperparameters, then you train it longer and you train it more. Yeah, exactly. Happy Wednesday. Good to see you. Elevator has guide rail. Hey, elevator has guide rail. Oh, elevator has guide rail. I like your name there. Happy Wednesday. Grand developer. Yeah. I'm in my 40s, you guys. So we're old here. We're a little old here. And it's all good, though. We still got energy. We still could make things happen even in our 40s. Anybody else lagging? Let me see here. We are 100% success. No dropped frames on our side. Okay, let's get into it. Let us get into this here. All right, let's go. Okay, now we are into this. So let's make our way. We are going to train our model now. Good evening, Jinlu. Good to see you. Welcome on in. I saw your switch statements on Discord. All right, so we got our epochs, our batch size. Let's also, wait, we could do this up here. We could do epochs. We'll do this here. Self dot, I would say, can you double equals on something in Pytorch or in Python? Hold on. Python. A equals 10, B equals 10. Can you do that? Yeah, you can. We can do, all right, let's do that. All right, perfect. Self dot units equals self. There we go. So that way we can leverage that. And we got our batches, and we got epoch. Self dot epochs equals 5. Something like that. I'm a code grandpa. Are you, Steve? Yeah, Stephen Howe on stream. Gonna genome. Oh, system tools. Work for mine on the 2005. Oh, yeah. We got the genome tools there. Hey, elevator, missed your message. Missed your message there. All right. Okay, let's go over here. We'll go into the training section. You know what? I think we are good to go. Let's make this over here so we can see this. Okay. Okay, so let's get into training. Optimization loop. Each epoch consists of 2 main parts, the training loop and the validation test state. Yeah, you can skip this part if you want. You can just do the training. You don't have to do the validation. It's not necessary, although it does help a lot because, you know how well is your model going to actually work? I sometimes skip this step. I don't always do the validation. I do some like brief validation in there. Thank you for the party poppers. How's it going there? MD, good to see ya. You wanted to help with something that you mostly coded in C, which is functional language. Now you're working with Python and it has classes. And for the love of you cannot understand. Oh, hey, don't worry, it's okay. It's okay, understanding comes later. Just sort of do a basic set of memorization. It's okay, thank you for the reactions, you guys. Do you have any references that talk about this? When to use a class and when to use a function. Usually use a function. If you're going to make when to use a class is if you're going to make multiple instances of it. That's it. Usually you don't need to do that. Use a function. It's always a function's the answer. Function is very rare. Hey, Action Capsule, what up? Good to see ya. Welcome on in. If chat doesn't mind, let's run an age survey. We don't ask that question. we don't ask that question. I've got your answer. Simon, you don't have to ask that question. I've already got the answer. Here, I'm going to show you. Don't answer that question, you guys. Do not answer that question. That's not something we do. It is a doxing question. Pytorch, yeah, elevator, Pytorch. We're doing it. All right, so studio. Here, I'll show you guys. I'll show you. 1 second. I'm pulling it up. I'm pulling up the stats. Analytics. All right, audience. Here, Savon, I've got your answer. We don't say doxing questions. Where's that at? Here we go. All right, I'm gonna zoom in. Here's the answer. There we go. Right there. We've got 25 to 34 is the winners, and then 35 to 40, 4, and then 18 to 24, 24. So here's the answer. Sorry, no worries yet. I got my Python backend action capsule. Nice, good job. I modded your own message. There you go. Yeah, here's the answer. So we get, and then 7%, so almost 10% in 45 to 54, and then 55 to 64 is 2%, and then over 65 is about 1%. So yeah, there you go. There's the answer. There you go. That's what we got there. So if you guys didn't know, now you do. Now you do. All right, let's get into our training. We're going to be using cross entropy loss. Nice. All right. Let me guess, your working schedule is changed for PubNub work for personal work because you do streams early, right? I'm trying to do early streams as much as possible because then that gives me enough time throughout the day to work with the rest of the team. I modded his moderated comment. He moderated sequence K. Is that accurate? It is, I think, yes. Please don't answer the question. Oh, yeah. Yeah, you don't need to answer. Don't answer. It's good. You're fine. When presented with some training data, our untrained network will likely not give correct answers. Actually, likely is the correct. Yeah, unlikely. Thank you for the hearts, you guys. Appreciate it. The loss functions measures the degree of dissimilarity. Why is it using big words? Of obtained results with a target value. It's just going to say we already know what the answers are when we're training the model. When the model guesses, it's going to be wrong. And then we're going to take the real answers and we're going to subtract that with the answers that the model guessed. And that's going to give us the difference. And that's the loss function. And you optimize for the loss differently based on what the number of answers are on the output. Do you have one answer? Is it possible there's 2 answers? Is it possible there's 10 answers? Like in our example here. Our data, we've got 10 possible answers. So this is 10 answers right here. Thank you for the hearts. Stephen, did you hear what Eon did recently? You mean Elon or I don't know. What did he do? Another spaceship? Try not smart, so gotta be funny. There you go. Yeah, that's the way to do it. Shivansh, good to see you. Hi, sir. Welcome on in. Are you a trader? Like, you mean like day trader, stock trading, high frequency trader, or quant? We've done that before. Do you trust AI if they are controlling your computer? No, not right now. Eventually I will. What did he do? What happened? So we got 10 right here. Where'd we go here? Did we click on something that took this the wrong direction? Where'd that go? Okay. I think I might have just scrolled. I scrolled a little bit too far. All right, so loss function. There it is. We're going to be doing cross entropy loss. So I'm going to put this loss up here inside my class. Self dot loss equals nn, right? Dot, what was it? Nn dot cross entropy. Cross entropy. Thusly, right? Loss. Okay. LOSs. So here's our loss function. They transferred the 125,000 neurons of a fly into a computer. I did see that. Elon did that? I didn't know that was Elon. Oh, Eon, not Elon. Oh, okay, got it. Who's Eon? You were a co-founder. Yeah, you're right. Elevator, good to have you here. How do you know this? What do you know? Tell me more. Tell me more. Chat more. That's not novel. Torva already had done mice and worms. I think longer game goes less. You should trust. Yes, exactly. The longer game. Exactly, Deuce. Exactly. You know it. You know it. Yep, exactly. Entropy is actually your username. Oh, entropy. The equation shortened. It's a just shorter equation. All right, so we've got our hyperparameters right here. Let's just hyperparameters. Right here, hyperparameters. And then these are our normal parameters right here. So like these are just parameters right here. These are the regular parameters. These are the regular ones. Powered, overlooked by the hyperparameters. These ones control how these ones learn. These are the controlling ones. S equals K log W. Oh, we got some math equations going on there. It's good to have you guys here. All right, let's keep going. So we've got our model, we've got our hyperparameters, we've got our loss function. Next, we need an optimizer. When we're doing backpropagation, the gradients that are calculated from the loss are just more arrays. They're more matrices. They're reversing through, when you do the forward pass on the model, we go forward pass. We say, hey model, what is the answer to, is this picture a boot? Is this picture a t-shirt? Is this picture of a cat? We ask the model that question. We pass through with matrix multiplications downward, like that. We go down, 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 every single layer. And then it gives us an answer. We're going to take the answer and we're going to apply our loss function to it. Then we're going to backpropagate, which means that we're going to reverse. We're going to take the loss and input it backward, like this. And it's going to give us deltas that we are going to be calling the gradients. We take those gradients and then we update each of these lines right here. These ones here, this one here, and this one here. Those three. We're going to be updating those parameters. Very lightly, based on the learning rate, we're going to multiply that so that way it's a smaller number when we adjust these parameters. And that's how we're going to train the model. Kind of like how humans learn. A little bit. Okay, we'll send it in link share, please. Yep, Torva, good idea. Share. Okay, sounds good. I think the replicated actually, because jumped from a mouse to a fly 20 to 70 million. Oh, yep, the bigger the brain. What I thought was interesting, when they put the fly into the simulated world, the fly was acting like a fly. That was impressive to me. I didn't think that was really neat. Transferred as a tool, actually biological material, and the soldier onto silicon. Ooh, hey Mark Lemon, good to see you. Thank you for saying hi. It's good to see you. You've been here on a regular basis, Mark Lemon. It's kind of good to see you. Again today, I feel like a table is afoot. A table? A table? What kind of table? All right, let's get our optimizer, you guys. Ooh, stochastic gradient descent. Optimization is a process of adjusting the model parameters to reduce the model error each training step. Optimization algorithms define how this process is performed. In this example, we'll use stochastic gradient descent. There we go. We got a virtual robot fly bug. Yeah, we did. We got a virtual one. And this was all predicted. This is the future. Look, this is how it works, you guys. They wrote in books and in articles that we are going to be, as hardware and our algorithms improve, we're going to add larger and larger animals into the ability to simulate them. We're at a fly, we're at a mouse. Eventually you'll get to dogs and elephants and those things, and then eventually you get to human. We're not there yet. We're not far off though. Anyways, gotta go, guys. Try to rejoin later. Sounds good, Savon. Be safe. Gotta do some IRL stuff. Sounds good. All optimization logic is encapsulated in the optimizer object. Here we use the stochastic gradient descent optimizer. Additionally, there are many different optimizers available. Let's check out the different options, you guys. Thanks for stopping by. Yeah, they simulated the entire brain and sensors it would experience so they could have one-to-one transfer the fly into digital being. How did they capture the neurons? That's one of my questions. How did they do that? How did they do it? Did they map every neuron's connection of an adult fly somehow? They must have done this. They must have sliced very thinly and used a electron microscope. That's the only thing I can guess. An electron microscope. How'd they capture it? Okay, let's look at the different. We've got a lot of optimizers. In the future, we'll be living in a program. If our Earth doesn't get destroyed by our humans. Yeah, you're right, Claude. You're right. Okay. Where are we at here? I wanted to see the different ones. Step closure. Where's all the different options? Optimizer, we got a bunch of different optimizer functions in here. Look at this. Perform a single optimization step to update parameters. Okay. Reset the gradients. We got to do that. Here we go. Algorithms. That's what I wanted. Hey, look at all the optimization algorithms, you guys. There's a lot in here. There's a lot more than I've only implemented this one right here, and I've gotten part of the way on these implementing by scratch. By my hand. This is my favorite one. SGD. And it's at the bottom. Why is it at the bottom? I assume they assume something quantum mechanics. Deuce. Okay. So we got some quantum. They're doing some quantum stuff here. What is the muon? LBFGS. Yeah, I get it. Implements the LBFGS algorithm. Yeah, all right. Why doesn't it just explain what it is here instead of just implements? They got to update their docs to be a little more helpful. Implements the average stochastic. Oh, ASGD. Oh, average. Okay. I didn't know about that one. I've used Atom before and the Atom W's. Atom Max. Implement Atom Max algorithm. A variant of the Atom based on infinity norm. Ooh. Still suspicious that AI is here masquerading as humans to be better to learn code. I don't know. I don't know, Sequence, the AIs, when they type code, I don't know if humans that can type code that fast. Not even me. Even Bug Brain is still a brain. That's true. Deuce, you know it. It still is. You're right. Wait, you mean it doesn't need it, right? You mean the context and so on is easy, just the bandwidth and context is the issue. In terms of compute and available information, yes, that is our current limitation, right? It seems like we should have plenty of compute. We just need to I feel like the algorithm also, Torva, I'd say the algorithm as well goes into that mix. Bandwidth and hardware and data and the algorithm. Those three combined. Autograd. Hey, there we go. Autograd. Add a factory and add a delta. Autograd. Does it give us information about Autograd? Adaptive subgradient methods for online learning and stochastic optimization. Ooh, and it includes stochastic, you guys. That's my favorite. I think Sequence K is talking to me. Got it. I'm keep checking in on the chat. Hey, Stephen Blum, how's it going there, Sergio? Hope you're having a beautiful day. I am. We're working good. Things are going well. We're all good here. We will be getting our expertise for Pytorch here pretty soon. That's what we're doing. So let's write our training. Let's do it. Let's make our training function work. Let's do it. Ooh, hello. Hello. Where did that happen? Oh, we got to get our optimizer. All right, so let's type this in. Torch optim SGD. So let's get our optimizer here. Self.optim equals torch.optim.sgd, I think, right? And then we go, oh, we need to do that down below. Okay. Model.parameters. Can we do that here? I think we can do it here. We'll find out. Recognize context loop example for a bigger context is just not made to be currently. Interesting. Okay. Model.parameters, LR learning rate. Okay, so we do have our LR equals self.learning rate. We've got that part. We can say model equals, model parameters. Okay. Parameters. Parameters. Like with S? Yes. There we go. So that means we have to do this down here. Let me go self.model. I think. Or this. Maybe we can do this. Let's see if we can do that. I wonder if we could do this. That would make me really happy if we could do that. This is a good reason. Okay, can we do this, you guys? Will that work? Will this work right here? Do you think this will work? I haven't done it this way before. And I like the organization of this. This makes me happy. All right, see if this works. Is it going to give us an error? Oh, it's not erroring out yet, but we'll find out. Oh, no. Okay, so optimizer got an empty parameter list. Yeah, fine. But we said self. Okay, we'll have to do it outside of this then, I guess. Fine. We'll do it here. We'll do it here. Model. Parameter self. I think, and then we say model.learning rate. All right, we'll do it there. It's not ideal. It's not ideal. Bye, bro. Meet you tomorrow, Claude. Sounds good. Thank you for stopping on by. Looking forward to that game when you get it. Looking forward to the game. All right. So let's see if that works now. The traditional way to do it. Fine. Yeah, there it goes. See you. It works fine now. All right. We'll do it that way. All right. Let's do the training. Bye, Claude. Good to have you here. All right, inside the training loop, optimization happens. We need to zero out the gradients from the optimizer to reset the gradients of the model parameters, which are here. Gradients by default add up, so they're additive. To prevent double counting, we explicitly zero them out each iteration. Okay. Backpropagate the prediction loss. We're going to calculate the loss, and we're going to, this will calculate the gradients, right? Pytorch deposits the gradients of the loss into the WRT each parameter. Oh, hey. Weight.r.t. I don't know what t is. We are cooking today. Hey, yeah, Sequence K, we're making our ways. We are cooking. Once we have our gradients, we'll call the optimizer.step, which is going to actually adjust the parameters at that point. That'll actually update that's where the model actually learns. We go into the model, we open it up, and we say, hey, we want to change these things, we want to change this one, and we want to change this one. Because we got 3 layers right there. Launch you later. Full implementation. Let's do this. All right. Model.train. This is going to enter the model into training mode. Set the model for training mode. Important for batch normalization and dropout layers. Right? Because if you have regularization, normalization, and dropout layers, if you want those for training in training mode. However, when you're not training, you want those to be turned off because you don't need that for inferencing. Unnecessary in this situation because we don't have those. Yep, we don't have those, but we're going to do it anyway because it's best practice. All right, train. Model.train, which doesn't actually train the model. It's really confusing. This is really confusing. Does not actually train. Instead, it enables some layers and things to be ready for training. That's what it does. It makes it ready for training. You're grasping at this? Just a few foundational elements that I'm missing to make this cohesive. Oh, the cohesion comes after a while. It does. So let's run this. Train. All right. Let's run this to make sure we're looking good here. No errors. Keep going. All right. Looks good. So we're going to run through our batches now and enumerate data loader. So we have our data loader. What's size? Where's size at? What is size being used here for? Why do we need this? Batch size. Oh, for math. For math purposes. Okay. So I'm going to ignore that for now. We might grab that later. Let's go through the batch, enumerate, and then the training. The batch is going to be the size. Okay, this is the current, if batch mod 100. This is the current batch. Okay. So we're going to enumerate the data loader. It's going to get us the features, which are going to be the images, the picture of the boot, the picture of the shirt, the picture of the ankle boot, the label, which is going to be the answer, the actual answer. So that's going to be like, this is actually a picture of pants. This is a picture of a dog or a picture of a cat. We're going to enumerate our data loader. So we have our data loader, I think, right? Data loader. Yeah, there it is right there. Data loader. All right. So we've got the data loader. Let us grab that data loader. And we are going to do something with it. All right. So for batch, comma, X, comma, Y, in enumerate. Okay. Print. We're just gonna print batch. Okay. The train data set needs to grab 1 second. Batch size is going to be based on model.batch. I believe. Hold on. Let's double check. Was it called batch? Batches. Okay. How about we say batch size? Like that. I think that's better. It's a little more obvious what's going on there. Hello from India. How's it going there, Daniel Phipps? Daniel Phipps from India. Welcome on in. Happy to have you here. Happy Wednesday. Let me check my calendar real quick, y'all. I want to make sure that I'm on schedule. And then we will continue. We will continue here. Okay, we're good. We got time. We got time, you guys. Okay. Double check. Looks good. Okay. India. Fellow from India. I'm over here in United States, Washington, Seattle. So we've got our batch size. We're going to put that here. Model batch size. Shuffle true. And I'm going to move this test sample down so that way we can look at that later, because it's nicer to see the stuff up here at the top. Okay. And then I want... that's fine. We're good to go. Train. Lower that down. Let's run this and make sure we're still working. Because there it is. Nice. Okay, good. That's a lot of batches. That's a lot of batches, you guys. Let's stop that. We'll stop that row. India, not in... Oh, Indiana. Yeah, okay, I got it. Yeah, sorry, I missed that. So you're also in the United States. You're in the state of Indiana. Got it. Okay, Daniel Phipps. I missed that. Apologies. The Torva, thank you for the correction. Appreciate it. All right, so we get another batch, and we will print the batch. Let's go through the back propagations. All right, so we need to get our answer. So prediction, which is the output, right? So the prediction equals model X. So that's going to give us the answer. It's not going to give us the correct answer because it doesn't know. What are you building, bro? We are building Pytorch tutorials. We're going to become Pytorch experts. So if you want to join me together, let's be Pytorch experts. We're going to become Pytorch experts. We're going through every single tutorial. We're messing with the tutorial. We're sort of making it our own. We're not going to be perfectly copy pasting everything. We're going to be making some adjustments. We'll be making a few adjustments on it. We're doing a few things. So first we need to get the answer from the model, and then we get our prediction. Print prediction. We're going to see what that looks like. So you can see every time the model answers, you can see what it looks like. And it's going to give us a tensor that's really big and expensive looking. Or error out completely. Tensor is argument on CPU. Where do we do this? Oh, maybe right here. Oh, we need to move. Okay, so dot to device, I believe. Let's do model.device. I believe we can do model.device around here somewhere, right? Can we do that? Hold on. Oh, model.toDevice. Okay. And we can also say self.device equals device. There we go. So that will allow us to make sure that we're on the same page. Model. That was in test. Okay. We want this up here in the train. All right. There we go. Oh, we did it already. All right. We did it. All right. Perfect. Hey, how's it going? The Ferris Bovine. Good to see you. Crazy. It was just crazy once they looked you in a rubber room. Oh, full of rats. Oh, wait. What are you doing? Crazy. What are you talking about? What are you doing over there? Okay. A little bit off topic there. Let's do the printing. All right, let's make sure this is working. So let's go back. Did we fix it? Is it good now? Hey, there we go. Look, now it's giving us the answers, you guys. Is it on MPS? I believe it is. It is on MPS. Okay, good. We're running on our accelerator. Hand over hash. Shop 256. Sequence K. York U. Stream. You've got a interesting hash. Oh, so you're concatenating? Okay, got it. And you're giving out a number. Hand over hash. What is the hand over hash? What is that? All right, so these are working. So we could do if batch mod 100 equals 0, then we can print this stuff out. I probably want like more than that. Let's go like maybe 10 so we can see things a little bit more instead of it going too crazy. No, maybe. All right, maybe we could do 100. Let's see. It's going pretty fast there. Maybe do a little bit of 100 right there. Yeah, that's good. Okay, is it? Yeah, 50. We'll do 50. Okay, 50. Let us do the loss, and then we are going to backpropagate to create our gradients, and then we're going to optimize, and then we're going to zero out the gradients. Okay, we can do that. We know how to do that. Print progress. Let's also do instead of doing prediction, let's do the progress. So batches. How many batches are there? So size. This is where size comes in. What's good, man? Great to see you. We're doing good. We're becoming Pytorch experts. We're going to go through every single Pytorch tutorial, and it's going to be a way that we become the expert in Pytorch. We're going to learn everything. We're going to learn it all. That's the plan. We want to grab, I want to do this. I want to do things. So I want to get the number of data samples. So there was a size in there. Data set. Okay, so let's do size equals, or I have length, number of samples, length, data set. Do we have to do times batch size? We do. We do. I knew it. Okay. Here we go. Length is going to be train data loader. Oh, is it data loader or data set? Data. You could do data loader. You could also do data set, I guess, right? So we have the image set right here. Can we just do this? Let's just skip over that. Let's skip over the, let's go straight to the source. Len, can we do that? And then let's do length. Yeah, length, right? The length of the data. I'm very curious to see if that's going to work. Let's see if that does. I didn't want to hype. You don't want to type out the full SHA. So you did a regular 6,000. All right. Ooh, nice. 60,000. Look at that. So you were acting like off to prove you are sequence K. Oh. Oh. Well, okay. All right. However you want to do it. Great to see you. Yeah, good to see you. Okay, so that's awesome. I'll try myself for a project. Hey, nice. Yeah, you should do it. Pytorch is the way to go. There's also JAX now, which is, you know, YouTube, Google's new approach. Got the JAX in there. Dude, it's interesting claiming anyone doesn't contribute anything else, then someone might know something, shouldn't know. Crazy. Wait, you're saying a whole bunch of words there, Deuce. What are you saying? Can you let me know what you're saying? I don't get it. I don't understand. Okay, so we've got our prediction. We're gonna print this out. We got the length, and I'm gonna get the progress. I want to print out the progress. So this is batch times batch size, self.batch size, divided by length. Maybe we would say total. I think total is a little bit better a word. Total's easier because we're total. There we go. Crazy. Yeah, maybe. I don't know. Okay. So that should give us the current progress in percentage. It's going, and we should multiply that by 100. So I'm going to get a percentage. So 100 times that way. Okay. And that will give us a percent. Print. Can we do comma percent like that? Okay. That will give us progress, I think. Let's check. Let's make sure it works. Self.batch. Oh, it's not called self. It's called model. There we go. All right. Looking good, you guys. Looking good. Hey, all right. Did we get it? All right. So we should also probably... Hey, nice. Okay, good. Let's do, instead of that, let's go to an F string. Like this. Like that. And here. And then we also want to... How do you... Is it colon dot F2? Is that right? Colon dot F2? Not that. Is it 2F? Yes, it is. There it goes. We know how to Python. There we go. Check that out. All right. Now we got our progress. We got a progress tracker. So we're going beyond the tutorial. We're doing a little bit extra stuff. Nothing that's crazy. So let us get the calculation. Let us calculate real quick. Let me look at my business here. Okay. We know how to pie. Yeah, we do, Jinlo. We know how to pie. It's a Rat King joke. Oh, really? I remember the Rat King story in Adventure Time. They had an episode fully dedicated to the Rat King. How's it going there, Godson Gene? Good to see you. Hi there. Welcome on in. Do you try to go with minimal packages? Otherwise, you can use TQDM for clean progress bar. Oh, yeah, we could have used a package, couldn't we? We sure could have. You're right. We could have. You thought your phone was going off just now? Me too. Because you heard a very similar notification? Well, things happen. Yeah, apologies. You're going to hear notifications every now and then because I've got my phone turned on. Okay. Now we've got our... I mean, we're good enough for here with the progress bar. We're fine. Okay. Now let's calculate our loss. equals model dot loss. We will have our prediction, comma, our answer. So let's print out the loss inside of this entire big statement. Okay, so let's go progress equals progress. Okay, and then we are going to print our f string here. We will call progress, and then our loss. Let's do our loss here. Loss colon dot 2f. That's it right there. Okay. Custom data. All right, you guys. Oh, the phone. Yeah, I know, right? Got the phone in there. So I believe we're good to go now. Now we're calculating the loss. We're not the model has not learned anything yet. There's nothing learned in the model yet. Let's see if we can run this though. Make sure it works good. Nope, there's a problem. All right. Do we need to... Right here, I think is the problem. Okay. I think we need to move. When we're calculating the loss, we might need to go dot detach, maybe? Maybe do it dot detach. Or to model device. Like that. I think, right? That should work right there. F dot, get rid of that. Okay. That should work. Shopping container repeating the lines over and over. It's a joke? Oh, is it? Oh, wait, I'm not familiar with that one. Oh, I feel like I'm always up to speed on all the memes because I'm like a big consumer of, internet culture. I'm a big consumer of internet culture, and I think I know all of them. Hey, there's our loss, and you know what? The loss is going to be the same no matter what because it's not learning anything yet. All right. So there's progress. Now let's actually train the model. You guys ready? Are you guys ready to train the model? Here we go. We're actually going to learn something. We're going to use loss.backward, which is going to calculate the gradients. Calculate gradients, which are just arrays that can be applied to our parameters, our layers. Basically, they're subtracted. Applied, subtracted to our parameters so the model can learn, in quotes, like that. I guess we were shipping more than words. Hey, Deuce, I see what you're doing there. Wait. It's niche. You'd understand Mog 3X better than I do. The good old Mog 3X. Oh yeah, the Mog 3X, of course. Good old Mog 3X. I have no idea what that is. I don't know what's going on in the Mog 3X. It sounds pretty niche though, like you're saying. Okay. So let's do the loss.backward. Calculating gradients. This will calculate the delta. How wrong the model's prediction was. So this is the loss right here. How wrong the model was. And it's going to be wrong. Usually, it's randomly initialized on weights, so sometimes it gets it right. It can't. It's got 1 in 10 chance, so it's got 1 in 10 chance. It's a pretty good chance. You're distracting by explaining the silliness earlier. My bad. No worries. No worries. Thank you for distracting. That's why we're here. We're here for you guys. Distract away. Now the model hasn't learned yet. We need to optimize. So let's validate that this is working and it hasn't crashed yet. All right, looking good. All right, good. Close it early. The device is still lagging severely. Uh-oh. The device? Which device? I think we're doing pretty good. We're going to now, finally, we're going to train the model. You guys ready? Finally, the model can learn. So that is our model. Wait, no, do we have an optim? Where's our optim at? Optim. Our optim's right here. Okay. So we're going to use the optim there. Optim dot optimize. Wait, hold on. Wait, what is it? Dot step. Okay, right. Step. So this one, you can step more than once if you want. You could go step, step, step if you really wanted to. Whole bunch of steps. You could do a bunch of steps if you want to. You totally could. And we are going to, then we're going to reset it. 0 grad, which sounds like a really fancy term, doesn't it? 0 grad, kind of like zero. You're deleting all of the gradients is what it means. I want it. It sounds way cooler than it is. It really is just, we're going to delete the gradients. That's it. It's my end. Got a Wireshark and a few others up monitoring. Oh, all right. Good to hear. Good to hear. Okay, so we're finally training now. Let's do this. Did we do it? We're just going to learn now. Okay. If we did this right. All right, you guys, I'm going to ask you on the poll. Let's see if we got it right. Let's do a poll. All right. Does this train method look correct? All right, that's the question to you guys. Does it look correct? Is it correct? Does this train method look correct? Did we do it right? You gotta let me know. We are, what are we learning here? Oh, Naveen Kumar, good to see you. Welcome on in, happy Wednesday. We are becoming Pytorch experts. We're going through every single Pytorch tutorial. And we're reading the tutorial and we're sort of making it our own. We're working through it together. I'm going to convert all of the fancy language that they use into regular human words, so it's easier to understand. The suspense music perfectly lined up. Yeah, it did. It worked pretty good. So we've been testing all the way up to this. So I believe the only thing that could possibly go wrong are these 2 items here, where the model is finally learning. I do think that it should work though. We should see a reduction in the loss. This number right here, you'll see our loss function is going to calculate how far wrong the model is. How wrong is the model? Awesome, yeah. I'm excited about this. This is where my passion is. This is what I get really excited about. I really like these things. We're learning artificial intelligence, you guys. All right, let's see if it works. We're gonna run it. Here we go. Boom. Is the loss gonna reduce? Is it gonna go down? It's reducing. It's reducing very slowly or not at all. A little bit. Okay, it learned kind of. We only did 1 epoch though. We only did 1 epoch and our learning rate was quite low. So technically, did it work? Yes, it technically did. How many epochs do we want? I suppose we go this. We say model.epochs for epoch in range train. Like that. You can do that. Okay. Train for set number of epochs. Here we go. The set number. We don't have those for n epochs. Okay. Which I do believe is something like 5. Yeah, it's 5. Okay. We can also increase our learning rate a smidge. Let's take a look to see how this adjusts now. A little bit better or a little bit, maybe our model's not that good. Maybe we got to fix our model. Maybe the model's broken. I think we might need to make some adjustments in our model. Shouldn't we optimize 0 grad before the step? You can do it both ways. You can do it both ways. Let's see here. Let's see if that makes a difference though. We'll try it. All right. Step. There you go. So the tutorial has it after, right? The tutorial has it after. So this is BTD music. I don't know what it is. So we'll try it. We'll try it the other way. Let's see what happens. Here we go. All right, now it's the other way. Is it different? It should be identical. And it is. Yeah, it's identical. Okay, our model's not learning. It's not broken, but it's not learning. Did we do it wrong? It's not learning enough. Maybe we need to really increase the learning rate, or we've got something wrong in our model. Because that's nowhere nearly enough learning. It needs to be way down. How's it going there, Loon? It's good to see you. Welcome on in. The music is YouTube. I like this song. This is one of my favorite songs. I know it's like it's really lighthearted, but it also goes hard. I like this one. Like, one of my favorite songs. I really like this one. Okay, so that didn't learn either. So you can do it either way. So actually, the problem is you probably want to do 0 grad here. right? Before you backpropagate. As if you're really going to do it that way, you probably want to do it there, if anything. Do we need to also set something else? Did I forget to do something here? Grad, where's it at? Oh, I'm doing that on the wrong side. Wrong screen, sorry. It's worse than coin flip. Wait, it is, exactly, yeah. We're gonna fix it though, don't worry, we'll fix it, you guys. You think the music's okay? Extremely nerdy music? Bring your random number generations in. Yeah, it's pretty nerdy. I think this song, I like this song. It's great. It's my favorite. It's Creative Commons for free YouTube studio music, right? It's right in the YouTube studio. I like it. It's called Splashing Around the Green Orbs. Okay. So what are we doing here? We are training an AI to learn to recognize pictures of clothing items. The clothing items that we have. I mean, that's just what we're doing right now. So here's the clothing items. T-shirt, trousers, pullovers, a dress coat, sandals, shirt, bag, and ankle boot. Who knows? Why can't it just be a boot? Why does it have to be an ankle boot? Probably because it doesn't only goes up to your ankle. So it's an ankle boot. Epochs equals question mark. Equals cute. We're good on epochs. I like this. Okay. So I think our grads here. So one thing I wanted to make sure is that our model, we do have it set to train. What if we don't train it? I want to see if there's a difference there. If we're noticing anything. It should be 0 difference. Okay. Actually, you know what? Let's run that again. Just to double check. Epochs equals 1 to 10 to 100. Oh, we should increase the epochs. Okay. Before we see it. I'm also going to increase the learning rate significantly. To see if there's something else wrong. Sorry, I want that song again. If you don't like it, we're gonna do the song again. If you don't like it, let me know. Otherwise, I'm gonna keep going. Okay, so I call that we need to increase some hyperparameters here. Let's make it massive, 20%. Way too big. Let's go way too big. Okay, there's something wrong. All right, we're going to figure it out. What's wrong with the model? Because that loss is incorrect. Network might be complex. Yeah, that could be it. Navdeen Kumar. It's actually a pretty straightforward model, though. Claude broke globally. Uh-oh. Wasted 30 minutes trying to log in. Oh, no. Hey, Redless Saber. Good to see you. Welcome on in. Happy Wednesday. All right, so let's take a peek here. Let's remove the sigmoid. Let's just remove the sigmoid. I don't think we need to. However, that's one thing that we have different from the tutorial is they don't have the sigmoid. It's just this. Like that. Okay. Python dataset. Vim. Yeah, Vim. Hello, what editor is he using? We're using Vim, you guys. See Vim right here. We got Vim, which is Vi improved. It adds colors, it adds a scripting language. It works really good. How's it going there, Reaper-son? Welcome on in. Good to see you. Hello. Hey, love your channel. I just started with Python. I'm working on a computer science degree. Oh, very nice to work alongside artificial intelligence. Let's do it. Let's make AI together. Labels, learning rate, wrong batch size. What do you think about vibe coding? Loons. I use it all the time. Every single day. Not while on stream. On stream, we're all about learning to code. We'll be learning new things. Is it better than VS Code? They're the same. It's a text editor. You can use whatever you want. And also, in today's age, when the AI is writing the code for you, does it really matter what editor you're using? It doesn't, because you're not editing that much anyway. Console.log, hello. Good to see ya. I saw your print statement there. Good to see you. Welcome on in. Happy Wednesday. Okay. Let's pop back over to this. All right, our model's not learning. Something broken, you guys. Something broke. Let us figure out what the thing is. What's the thing that's broken? What do we do? All right. Linear value stack sequence, flatten. We've got the flatten. We're good to go there. All looking good. We got our data loader. We got a batch size. Batch size is fine. You're thinking of getting a job as a junior Python developer. Any tips? Chronocipher. If you want to get a job, you have to stand out. right? You have to stand out upon all the other software engineers in the world. One way to stand out is to build an app. You release the app and you get users. And then you start talking to those users, getting feedback from those users, modifying your app, and then making it better. And you go through that cycle multiple times. That is one way to stand out. User acquisition is a challenge, especially nowadays and age when the coding is done for you mostly automatic with Claude, Codex, Gemini, Brock. There's a lot of coding agents out there. You don't need to worry about coding so much anymore. Do you have any advice on learning Python? Any early advice that you wish you knew? I would like to have gone through the Python basics first. Just the basics, simple basics, and then knowing that I need to write an app to help you memorize. You have to go through that step. You got to memorize. If you really want to. I mean, do you need to? Do you need to? Do you even need to? I don't know. Already burnt out your job? Oh no, are you? Now you want a cow farm or chicken farm? You want to become a farmer? Well, you can simulate that with Stardew Valley if you want. Thank you so much for the advice. You're welcome. Absolutely. Do you use Tableau or visual input? Or tabular or visual input? If it's images, you need convolutional layers instead of linear ones. Ah, yes. Well, you don't need that. It's not mandatory. You don't need them. Convolutional? Yes, it's better because you've got multiple filters. You can do it. So you can calculate the edges and stuff. You don't need it though. It's not mandatory. For the MNIST dataset, you typically only need a simple stack like this right here. That's it. You only need a simple stack. Did I miss any of your chat messages, you guys? Advise, custom. Oh, you build a custom git diff GUI. It looks awesome. Gonna publish it to GitHub on your Discord. Sounds great. Code Langton's Entropy. Fantastic. Loving the stream so far. Sounds good. It's nice to have it running in the background. Hey, good feedback. Appreciate it. Nobody took you seriously. They didn't, not in tech, until you started doing IoT security devices. Ah, Arduino and analog computing. The best kind of security, you just turn everything off, and then it's secure. It's maxed out on security. How can we use the model to test? Which model? Oh, to test? Well, there's some test data sets here, which we could also load in. We've downloaded it locally on our computer. Can we please get a contact of yours? Discord. ChronoCypher. Discord, yes. So hit me up on a direct message on Discord. So over here, copy link over here at Chrono. Send me a direct message on Discord, and that's how you'll do it. Okay, let's look to see what our challenges are. Let's look here. So we've got our sequence stack. We're looking good. We've flattened our data. We've got our logits. Please suggest top 5 apps to build. That's a lot to suggest. That's a lot to suggest. That's the truth. You can still lift into, off, and air gap a computer. Yeah, that's the way to do it. At least 3 to 5 ways. The DC link is also in Steven's link tree. Oh, Torva, yes, thank you. It's also in the link tree, you guys. So we've got a slightly different setup here, sort of. Super init. So go here. We've got our super init. I think it would break otherwise if we didn't have it right. What are some of the hyperparameters? Let's look at the hyperparameters and see what they set. So they're setting it to a lower learning rate than I have. They set it to 0.03. We have it set to 0.2, which is too big. But, you know, something like this should be really fine. That should be fine. Let's try 0.03 though. We'll do 0.03, which is identical to this, right? So let's convert this Python. That is 0.01. Sorry, 0.01, like that. Okay. So that's their learning rate. We could do that. Also, I might change these to be different than ReLU. We might do that. Okay. You can we want to All right, so we got our cross. Yep, we got our cross entropy loss, which was right here. Looking good. Our optimizer. We've got our model parameters and our learning rate, which is our optimizer. Our model looks like this, which is identical to the model here, I believe. Yep, linear, ReLU, linear, ReLU, linear, right here. And then our units are 512, so it's identical. Top 2 apps? Well, what would be a good app? So I don't know. What are? Let me look this up. Right. So App Store. Let's look at the top apps in the App Store right now. How do we see? Open the App Store. Okay. Apps. Okay. Well, if we're looking at this right now, most of it looks like it is social media and gaming and streaming, and so entertainment. Those are the top apps. What you should build, that's a tough one. That's difficult, you guys. A video editor is a fun one. Those do pretty good because media, social media, right? I think there's a lot of users on the internet. They need a video editor that edits videos more automatically. There you go. I'm only going to give you the one. You only get one. You get one. One answer is the answer. Build a video editor that edits videos automatically. The user should not have to manually edit the video. Don't forget to like and subscribe, you guys. Yes, Sequence K. Thank you. If you like the stream, press the like button, click the subscribe. Good to have you guys here. Happy Wednesday, everyone. Good to see you. All right. So let me check my time real quick. I think we got 20 minutes, which is plenty of time. Plenty of time. Got 20 minutes, you guys. God sent. Yep, you're welcome. What is wrong with the model here? Hey, Steven, Torva, thought of an idea that may be good tab architecture. If you have a tab open for more than a certain amount of time, feeds into an AI, then automatically makes a bookmark inside a folder. Oh, yeah, that might be good. I have a lot of open tabs. Side quest comment, have you ever used Android? Yes, I am an Android user. This is Android right here. Android, you guys. What's up? How's it going there, Jayton E. Ada? Welcome on in. Good to see you. Happy Wednesday. We are learning Pytorch, you guys. Let's do this together. All right, the optimization loop. We got our loss function. Looks good. We have our... Let's double check our optimizer. Optimizer, stochastic gradient descent, model up parameters, learning rate equals model up learning rate. Double check. Yes. Okay. Okay. All right. Phew. Okay. LOL. Wait. Yeah. I think. Really? Oh, what were you? Were you worried? Let's get rid of that. We never use label map. There's no need for this. We just don't use it. Label map L is a map. There's absolutely no need for this. So L is going to be an iterator. Is going to be a number. But you don't need that though. You just don't need it because you've got your labels array here, which is already indexed by integer. We just don't need this. So I'm gonna hide this because we just don't need it. Hide that. Okay. We got our data set here. Optimize, batch. Something ain't working. All right. Well, don't worry. We'll figure this out. Let's run it here. Okay. Oh, look at that. Okay, so it is, see how it was very high at the beginning? It had 11. It should be going below 2, at least, or below 1. It should be, at least. So, let's go. My progress meter needs to be updated. Let's update the progress meter. That's not going to fix anything. I just feel like that's something I want to update right now while we think about it. Hey, Steven, how have you been? We've been doing good, Akash. Good to see you. Happy Wednesday. We are learning Pytorch together, you guys. Becoming experts at Pytorch. Let's make it happen. We need to also add in the total times epochs. So it'll be times epoch. Oh, you know what? Instead, let's go over here. Times model.epochs. There we go. And then we need to also do that here. Epoch. Model.epochs. There we go. So this gives us the actual full. Okay. Yeah, look at that. That's weird. Okay. I'm going to do something different. Instead of using ReLU, let's do, let me see. Can we do tan H? Can we do that? Let's try tan H. We'll do sigmoid out. Cannot stand iPhone because of how locked up it is. Also the exclusive hardware software. Yeah. You know it. I like the openness of Android as well. I'm very happy about Android. Okay. Oh, hey. Oh. That's not quite what we wanted. Why is that not? Did I not save it? Did I not save it? What's the deal? Okay. Model times epoch. Do we... No. We need to do some addition here. We got to do some addition. Current epoch. Enumerate, because we train it more than once. The current epoch. Okay. We'll say epoch here. We got to do it like this, otherwise it won't work. Epoch. The current epoch. Okay. So we fixed our progress bar, probably. However, we did not fit. Well, we broke our. No, did we? Oh, there it goes. Okay. Why was it 0 so early on? That's crazy. Okay. Oh, it is. It's not. Oh, we didn't fully fix it. Current batch. Epoch. So I suppose we could say, oh, plus 1. 1 plus epoch. We get the current epoch. Then we need the current batch and the batch size. And then we get the total epochs. Here. Okay, great. But it's still not learning. It's still not learning, which is the problem. Okay. It goes back down to 0. Because why does it do that? Why does it go back down to 0? This shouldn't go back down to 0. Current epoch times batch. Oh, because batch. Okay, so let's do plus 1 here. 1 plus batch. This. Because batch hits 0. If batch is hitting 0, then that's a problem. Because that will reset it. Okay. So now it looks good. We just need to see why the model ain't learning right. Yo, how's it going there, Ryzen CPU? Good to see you. Happy Wednesday. We're learning. Oh, it went back down to 0 again. Why did it do that? That was weird. It shouldn't be doing that, I don't think. So, oh, because batch does go back down. We need the current batch. The loop doesn't work without proper batch. This is proper batch. Oh wait, so tell me more. Tell me more. What are you thinking? What are you thinking? Because we do have proper batching right here, right? This gets us the batch, the current batch. And so if we say print, this will be 64. Or the current batch number, right? This is the current batch. So we should see like a number of, yep. And that number keeps going up. And then it starts over when it hits the next epoch. So, where'd that go? Where'd that go? Here it is, right here. Okay. Right, it starts back over to 0. So we need to do some extra math there. What model are you training? This is the fashion imnist. So it's a bunch of pictures of cloth. It's clothing. It's clothing item. Right now, for whatever reason, it's kind of broken. We will figure it out though. We will. What is the current time? All right, we got 17 minutes to figure it out. It would be great if we could figure this out. That was like the whole goal of today's stream. If we could figure this out, you guys, I think we will do a good job. We will do a very good job. All right. So batch is the current batch. And then we got our epoch. The epoch needs to be multiplied by the current size. So if we have size equals, and then we use the size on the epoch. So we go epoch times size. like this. And then I suppose we start out 0 is fine, right? And then we've got our batch. If that goes to 0, that'll break. Oh, so let's go 1. 1 plus, like that. Then we've got our bat. All right, so that might have done it. Although that will immediately. No, wait, this can't be +1. There we go. Okay, much better. Although, if it. Here we go. All right, we got to do +1 here. Okay. So do +1 here. You know what? It's fine. We don't need to. No, we do for the initial run through, the initial epoch. It does. So it does have to be +1. 1 plus. Okay. Need more info. It looks like the epoch batch relation is not set correctly. Does that designate one epoch? This is. So we're sidetracked right now. So the actual broken thing is the model isn't learning because we don't see a reduction in the loss. Oops. Let's bring this out here. Okay, let's run that again. See, the loss is stuck at 2.3. So if 2.3, that's not good. We can't have it stuck at 2.3. Oh, look at the percentage. It's way too big. Yeah, that's right. We fixed that one, didn't we? Uh-huh. Good job. Jeez. Yeah. Hey, Quantified Quantum. Good to see you. Welcome in. Happy Wednesday. We're looking to train a model here. And then I've got my math all weird. Current batch times batch size. All right, so this needs to go in here. Like that. And then I suppose we could hide that. So the current batch is going to go to 1 in the batch. So otherwise, that if we don't say +1 here, it's going to be a problem. +1. Like that. Okay. Gotta go. Bye. All right, Loons, good to see you. Happy Wednesday. Have a great day. Okay, so I want to make this work. Let's see if we can make that work now. I'm not confident that it's going to be the ultimate fix here. Welcome to the stream. About 15 minutes left. Yeah, we got 15 minutes left, you guys. Then I got to head out. All right, that number's way too big. So it happens here when the size and epoch get into the picture. Size is the total length times the total number of epochs will give us the size. So I want, once we get through one epoch, I want to add in the size pool. Oh, it can't be multiplicative, it has to be additive. Okay. Let's try that. Okay. See if that works. Like and subscribe. Yeah, Sequence K, thank you. Ooh. Oh, hey, there we go. All right, so pretend 100%. Oh, okay, no, that's still not good. We can do math. I feel like it's like the easiest thing. Okay. We should be able to easily do this. All right. Batch size model epoch. Size times epoch. So we don't need this +1 anymore. Right? Don't need the +1. I think. Okay. So that'll fix the initial. That'll fix the initial problem. And then once it gets to the next epoch, it's going to break again. All right. Yeah, see, it breaks again. So size is up there. Image data. So 60,000 samples. The current batch. Oh, so we should divide by batch size. We're getting into crazy. We're procrastinating right now. Like we really are. What we should be doing is fixing the actual model. Hey, I'm back. What's happening? I try hard. We need your help. We need your help. Our model isn't learning. 60,000 samples. Yep, that's the 60,000 sample size. And then it balloons up when you get to the next epoch. Each epoch it goes up. So I suppose what we could do is we could just say epoch. And we can say epoch. We're just going to simplify it. We'll pull this around so that way it's like this on this side. Okay. And instead of doing all this mathy math up here, we'll just go like this. Yeah, there we go. Perfect. Okay. So that's better. Now the math works, however, of progress equals epoch number. Oh, what? Really? Batch times model batch over total. That should totally work. That should work. I don't know why it's not working. We broke it! Oh, well, whatever. What's the error stack trace like? Oh, there's no stack trace. It's not broken. It's just not learning. So what we need to do is we need to figure out why it's not learning. We even changed up some of the model hyperparameters and things like that. So this is like really simple stuff. Like why'd we not, why it broken? Why is it broken? Let's try this. Okay. Let's try that now. Okay. There we go. Same problem as before. Okay. Good to know. Are we doing this? Maybe we're doing this properly? Do we have it? Are we doing the right? So I got less than 10 minutes, you guys. Less than 10 minutes to go. It's loss prediction.item. Where's our loss at? Model.eval. Model.train. Prediction in y, our loss function. Right? So where's that at? Here. Right here. Prediction. That part looks good. All right, we're going to figure this out. If it's not learning, try a higher learning rate to start. If it doesn't learn, it means usually your optimizers and loss functions are a problem. Got it. Okay. So we're going through the tutorial, which is surprising because you'd think that the tutorial would have it right. However, we've seen the tutorial be wrong before. We've definitely seen it wrong before. So does it learn? See, this one is learning. So you can see the loss is reducing over time. So it starts out at 3, and then it drops down to 0.14. That's what we want to see. Yeah, tutorials are bad. Data sets are you working with? This is just a standard fashion MNIST. So it is in the ls fashion MNIST directory. So you can see vi fashion MNIST train. So you can see it's just a bunch of images. So we got images and their counterpart label. Really simple, really simple. What's the loss function you're using? It is a cross entropy loss. Cross. Right here. That's it right there. Whoa, isn't it working? Usually it works just fine. Reason it fails, always the semicolon. I know, right? It's always the semicolon. Python doesn't have any of those. Yeah, so it could be indentation. So this seems like it should be working fine. It's not though. All right, so we can increase the learning rate. Let's try that. Okay, we're trying to increase the learning rate there. And then as you can see, the loss right here, it maintains its position. It doesn't reduce. Oh, I didn't get notification. Oh, Kyle, hey, good to see you. No worries. We got 10 minutes left. Yeah, for cross entropy loss, linear units 10. Yes, that's it. Exactly. Exactly. Is that dropping a smidge? No, not really. Okay. Yeah. So here's the whole picture. Right there. Here's the whole picture. Use ReLU for the activation functions. Okay. Well, hold on. 1 second. All right. There you go. Okay. Activation function active. They are activated. They are activated. Use 10H for the prediction layer. Okay. There you go. 10H for the prediction layer. Is that thing trained yet? Well, we're right on it. I know it's the whole goal of the stream. We got 7 minutes left. Can we do it in 7 minutes? I don't know. I don't know if we can get it done in 7 minutes. We should be able to be because it's basically all done. Now we're just like tweaking the little parameters. ReLU for activation, 10H for the prediction layer. We are training it up. How's it going? 70 minutes? I know, right? Could be 70 minutes. We own 7. Just actually 6 now. 6 minutes, you guys. We got 6 minutes left. All right, let's try it again. Let's try it again. I made it. It made it different. It did do something different. Is it learning though? It might. It might be. That might have done the trick. Maybe. I don't know. It's trying. It's trying. Linear units 10 instead of sigmoid. Yes. Okay, so we got rid of sigmoid. Oh, got it. Okay, so instead of the output. Okay, so nn dot linear units 10. Oh, we've already done that. We already had that here. So we could get rid of that. Yeah, so we already have this part. Did that learn? It did not learn. It didn't learn. Okay, so let's try it without the tanh. Let's see if that works. Nope. Why no worky? Yeah, it's not working. Okay. 5 minutes. We got 5 minutes. We gotta figure it out in 5 minutes, you guys. Otherwise, we'll have to figure it out tomorrow. We'll have to figure it out tomorrow. All good. Lock in, bro. I know we're locking in. We're trying. So we got everything. Everything's set up perfectly fine. It's all good. It's all happy. That won't work. Usually you need a sigmoid or tanh. Yeah, exactly. That's usually, you got it, because it's classes there. Is this repo pushed somewhere? We can make it pushed somewhere. We could. It's actually just a single file. It's actually really short. It's really short. Here, I will copy it and paste it in Discord, so you can see it in Discord. Okay, I'll put it over in Discord under link share. Let's see if we can do a. Well, here. Okay, I'll put it into a thread. Okay, under link share. All right, so this is our Pytorch tutorial code so far, and we'll put it into a thread so it doesn't explode the screen. 1, 2, 3 Python. There you go. Message is too long. No. Oh no. Okay, we can get rid of the test sample. I don't know if that's going to get rid of enough of it though. Oh, it did. Okay, perfect. Okay, there it is. It's on Discord now, you guys. Well, we got more people here now. Hey, all right. Good to have you guys here. Git commit training fail. I know, right? That's a single script. It is. It's really simple. It shouldn't be. It should be working. So let me increase this to like 5. Let's go beefy. Let's go beefy. Let's try this. While that's running. Okay. So that did change the loss. It did. So especially with the tanh output, because it's more sensitive to a large learning rate. Hey, Dylan, good to see you. What are we doing? We're becoming Pytorch experts. We're working right now to try to fix this tutorial that definitely is broken somehow. There's something broken with it, and we've got 3 minutes left, and then we have to go. We're right at we're at the bottom minute, you guys. We're at the bottom minute. There's just a few left. A few moments left. Why is that doing what that is right there? Let's get rid of the equal sign on that. We don't need that. This was working before. Oh, total. It's not total. Yeah, total's the right side. Yeah, that's total. Total equals epochs times size. Oh, right. Oh, that should have been at the answer the whole time. It should have. Right there. Oh, right. And then the batch needs to be... All right, I've got a better idea. Okay. Someone do something. I know. We're right at we've got 2 minutes left. What's going on? Tiny Rick. Good to see you, Tiny Rick. We're trying to fix our AI model that we wrote from the tutorial. It's right here in the Discord, and we've got 1 minute left. We got 1.5 minutes, and I got to get going. It was a lot of fun, you guys. We will fix this tomorrow. We will. It looks like we've got everything proper and correct. Everything is correct. It's all good to go. It is. It's just one. The problem is total. Oh, this needs to be not total. This needs to be size. Size. Here we go. Okay. So that can't be. Oh, right. Okay, that's fine. Okay. It's not learning. You can see the number is not reducing. All right, you guys. 1 minute left. We got 1 minute. Let me really boost this up to some number that's obnoxiously large. We could also reduce the batch sizes down to 4. Like, let's try 5 batch. Let's do a size of like 4. We'll do 4, 0, 3, Okay, let's try this. Okay. Any progress there? No. No progress there. It's not. Oh, it dropped down to 1 for a second. I don't know, you guys. I don't know. All right, that's it. 20 seconds left. We didn't do it. We didn't do it. Okay, so the plan is for tomorrow. We'll be back tomorrow, you guys, and we will fix it. I'll stay right on Discord, and I need the code to speak to me. All right, sounds good. It looks like it's perfect. It looks like it's perfect, and it should work perfectly fine because it's a tutorial. It's a tutorial, guys. All right. Had so much fun. Enjoyed meeting you guys today. We'll be back tomorrow. We'll fix the model, and we will have on to the next part of the tutorial, which is going to be... The next part of the tutorial will be save and load the model. Okay, that's next. All right, see you guys. It's been a pleasure. Good to see you. See you guys back tomorrow. Bye, everybody. See you tomorrow. Thank you for joining. Been a pleasure. See ya. Thank you. Bye, guys.